In this video, I'm going to talk about the applications of the three most important basic algebraic identities in the world. How we obtain these three identities is discussed in another video, whose link is at the top right corner. The three most important algebraic identities are the difference of squares, the square of sum, and the square of difference. These three identities have a lot of linkage to different concepts of mathematics and a lot of neat applications. For example, these two identities are very useful for completing squares, which is the critical technique in developing the quadratic formula. The bottom identity is also useful for developing something called the AMGM inequality. Furthermore, both of these identities are related to the binomial theorem and Pascal triangle. In particular, let's try to write down just the coefficients of each term. X means 1x, so I'm going to write 1 here. Y means 1 times y, so the coefficient is 1. X squared means 1 times x squared, so it's 1. This is obviously 2, while this one is also 1. Do you notice that 11 squared is exactly 121? This is not an accident, and let me try to explain it to you here. Think of x as the number 10 and y as the number 1. Then 10 plus 1 is exactly our 11. How about x squared? It is 10 squared, so it's 100. 2 times x times y is 2 times 10 times 1, so it's 20. And y squared is 1 squared, so it's 1. Adding them up is exactly our 121. In case you find yourself often forgetting this square of some identity, try to relate it to 11 squared is 121, and you might find it easier to remember. This idea also works for the last identity, but I'm going to leave it to you to figure it out. These two identities are incredibly useful, but I would say that the difference of squares formula is the most important one in the world. In the rest of this video, I'm going to demonstrate how to use the difference of squares formula to do some mental math tricks. Let's try to calculate 47 times 53. Instead of directly multiplying them, let's think about 47 as 50 minus 3, and think about 53 as 50 plus 3. In this way, our product fits with the difference of two squares identity perfectly. Think of 50 as our x. Think of 3 as our y. The first parenthesis is exactly x minus y, while the second parenthesis is x plus y. According to the difference of two squares formula, we will get x squared minus y squared as the product. And x is representing 50, so we have 50 squared minus 3 squared. 50 squared is easy. It's just 25 with 2 zeros behind it. 3 squared is just 9. When we take the difference, we get the final answer, 2491, as the final answer. Alright, that's good. But when we were given two numbers to multiply, how did we realize what x and y are? The way to think about it is as follows. 47 and 53 has the midpoint 50. By midpoint, I was thinking about the real number line with two numbers 47 and 53 on it. The midpoint between these two numbers, which is also the average between 47 and 53, is 50. And the distance from both numbers to 50 is 3. Therefore, we have 47 expressed as 50 minus 3, and 53 is 50 plus 3. Let's practice once more by multiplying 72 with 68. The midpoint between 72 and 68 is 70. 72 is 70 plus 2, and 68 is 70 minus 2. The difference of two squares formula will give us 70 squared minus 2 squared, which is 4,900 minus 4. And the final answer is 4,896. We can also use the difference of two squares formula the other way round. For example, if we want to calculate 36 squared minus 34 squared, instead of squaring each number and then take the difference, we can use the difference of two squares identity to rewrite it as 36 plus 34 times 36 minus 34. 36 plus 34 is 70, while 36 minus 34 is 2. So the final answer is 140. That's pretty quick, isn't it? Or if you want to calculate 59 squared minus 51 squared, again, instead of squaring each number and then take the difference, we can try to rewrite it as 59 plus 51 times 59 minus 51. 59 plus 51 is 110, while 59 minus 51 is 8. So the final answer is 880. Thank you very much for watching this video. If you like it, please subscribe to our channel and we will learn more fun math together. Thank you.